Hi, I'm Don Watson. I'm here to demonstrate a powerful new tool that helps elementary school children prepare for algebra. It's based on a paper published by the Ontario Association for Mathematics Education. There are two different ways of viewing many mathematical concepts, as active processes or as static and abstract. Anne Svard says in one of her papers that we first need to introduce concepts as active processes. Then students have a better chance of understanding them. Our present method, introducing algebraic concepts as static and abstract, she says is of little or no avail. I believe that we need to respond to what Svard has said and introduce algebraic concepts as active processes. If you could spare a few minutes, I'll demonstrate how. I'll need a new and simple notation called foundation.
Foundation may be different from anything you've seen before. You may wish to watch this video more than once. With an on-screen keyboard, I can do everything by pointing. There is also a minimum keyboard down the right-hand side. This is foundation's variable. If I touch the variable, it opens up, and I can key a number. When I key enter, the variable takes in the number. A variable can take in any number we give it. There's the generality we need. Also, because our variable took in numbers, it was active and concrete. Nothing was abstract. Foundation is built from simple number machines. Here's an addition machine. Let's give both variables a number to take in. To do the calculation, we can bring up the calculate icon and point to it. So our addition machine has taken in two numbers, 5 and 7, and produced an output number, 12. Taking in numbers and outputting a number is what concrete functions do. So these number machines are simple, concrete functions. Let's try a multiplication. We can also get variables to take in numbers by dragging them. Again, our function took in numbers and produced an output number. Nothing was abstract. Obviously, the same answer of 15 can be achieved by counting 3 rows of 5 objects. Early grade students need to be convinced that Foundation's answers fit the real world. In this way, students could develop some concrete understanding of variables and functions in the early grades. What about expressions? Let's compare two Foundation functions with their algebra equivalent. These two functions multiply by 5. These two add 4. But Foundation can do things that algebra can't. We can let the plus 4 function take in the 5 times function. So Foundation variables not only take in numbers, they take in functions. We now have a function expression built from two simple functions. An expression like this is also a calculation algorithm. Let's give the remaining variable a number to take in. This icon does one calculation at a time. We did the multiplication, now the addition. Notice that the output from the multiplication, 80, was input to the addition function. The expression we built was concrete. Nothing was abstract. Now let's move to a higher grade and build a more complex expression. We'll find a hypotenuse function using Pythagoras. We'll need an addition function, 2 squaring functions, and a square root function. Bring out the addition function. Drag a squaring function into each of its variables. Notice how easy this manipulation is. Bring out the square root function and drag this whole Foundation expression. Notice how easy it is to manipulate whole expressions in Foundation. In algebra, this is hard for students to understand. Drag the expression into the square root function. We now have an active calculation algorithm for Pythagoras. Let's give its variables values. And we'll calculate one stage at a time. Notice the way the squaring functions each fed their output as input to the addition function, and the addition function fed its output as input to the square root function. Here are three copies of the Pythagoras function. If the variables take in numbers, we have arithmetic. So far, we've dealt with generality, with functions, and with expressions in a concrete way. We can now add the abstraction of algebra separately. If foundation variables take in letters, we have algebra. So foundation is a computer tool that links arithmetic and algebra, a stepping stone between. We can take an algebraic expression and flip any variable to show its concrete side. On this concrete side, variables can take in numbers. And we can demonstrate algebra's relationship to the real world by calculating. To learn more about this tool, you can visit its website, read the teacher guide, and try out Foundation. The website is at www.foundationnotation.com.
Foundation can test algebraic theorems in the same way that science labs test scientific theories. We just put numbers into the variables and calculate. Anything you can tell us through our blog, Facebook, or Twitter will be greatly appreciated. Your feedback will be used to improve Foundation. It'll be upgraded transparently with new versions as we learn what's needed. Foundation is intended for elementary schools, but may also be useful in high schools, although there will be a second package for high schools built on top of Foundation. Thank you for listening. We're sure that you'll enjoy Foundation as a useful teaching tool.